The universe is a vast and enigmatic stage. We as humans are accustomed to observing the grand spectacle of stars and galaxies, planets and moons. But there exists another, more subtle performance, hidden beneath the surface of our everyday perception. This is the silent theater of the quantum world. It is a realm of baffling paradoxes and mind-boggling possibilities. Here, particles dance to the rhythm of probability, defying the classical laws of physics. Join us as we venture into this strange and wonderful dimension. Our journey into the quantum realm begins with a simple realization. The world is not always as it seems. The solid objects we touch, the predictable movements of celestial bodies, all these familiar phenomena dissolve into a fuzzy, uncertain reality at the smallest scales. To understand this hidden realm, we must abandon our classical intuitions and embrace a new kind of logic. In the quantum world, certainty gives way to probability. Imagine a game of cosmic dice, where the outcome of each roll determines the properties of particles. Unlike our familiar dice, however, these quantum dice never quite settle on a definite result. Instead, they exist in a superposition of states, a blend of all possible outcomes existing simultaneously. The wave function, a mathematical concept in quantum mechanics, describes this probabilistic dance of particles. It tells us the likelihood of finding a particle at a particular location or with a specific energy. But it cannot pinpoint these properties with absolute certainty. The act of measurement collapses the wave function, forcing the particle to choose one state from its superposition. Until then, it exists in a limbo of possibilities. The inherent uncertainty of the quantum world is not a limitation of our instruments or our understanding. It is a fundamental principle woven into the fabric of reality itself. Werner Heisenberg's uncertainty principle, one of the cornerstones of quantum mechanics, formalizes this cosmic dance of limits. This principle states that we cannot know both the position and momentum of a particle with perfect accuracy. The more precisely we measure one quantity, the fuzzier our knowledge of the other becomes. It is as if the universe itself imposes a fundamental limit on what we can know about its smallest constituents. This inherent uncertainty is not a sign of our ignorance, but a testament to the rich tapestry of possibilities that defines the quantum realm. The bizarre implications of quantum mechanics did not sit well with all physicists. Albert Einstein, despite his pivotal role in the development of quantum theory, remained skeptical of its more radical interpretations. He famously challenged the notion of quantum entanglement, calling it spooky action at a distance. Entanglement, one of the most perplexing phenomena in quantum mechanics, describes the intimate connection between two or more particles. Once entangled, these particles share a destiny, their fates intertwined regardless of the distance separating them. Measuring the state of one particle instantaneously determines the state of its entangled partner, even if they are light years apart. The observer effect. Does awareness shape reality? The enigmatic nature of quantum mechanics inevitably raises profound philosophical questions about the role of the observer in shaping reality. Does the act of observation, the interaction between our consciousness and the quantum world, collapse the wave function and force particles to choose a definite state? The Copenhagen interpretation, one of the earliest and most widely accepted interpretations of quantum mechanics, suggests that it does. According to this view, reality at the quantum level remains in a superposition of states until an observation is made. It is the act of measurement that disrupts this delicate dance of possibilities and forces the particle to assume a definite reality. This interpretation has profound implications for our understanding of the relationship between the observer and the observed, suggesting that consciousness itself plays a role in shaping the fabric of reality. Schrödinger's cat, a feline paradox. To illustrate the paradoxical nature of quantum superposition and the role of observation, Erwin Schrödinger devised a thought experiment that has since become a cornerstone of popular physics, Schrödinger's cat. Imagine a cat sealed inside a box with a device that has a 50% chance of releasing a lethal poison. Until we open the box and observe the cat, it exists in a superposition of states, both alive and dead. Only through the act of observation do we collapse the wave function and determine the cat's fate. Schrödinger's cat, while a thought experiment, highlights the profound strangeness of quantum mechanics, where reality seems to be defined by the act of observation. Many worlds, a multiverse of possibilities. While the Copenhagen interpretation suggests that observation collapses the wave function into a single reality, the many worlds interpretation offers a more radical perspective. Proposed by Hugh Everett III, this interpretation suggests that all possible outcomes of a quantum measurement actually occur, but each in a separate parallel universe. In this view, every time we make a measurement, the universe splits into multiple copies, each representing a different outcome. The cat is both alive and dead, but in different branches of reality. This mind-boggling concept, while highly speculative, offers a compelling solution to the measurement problem in quantum mechanics. It suggests that all possibilities inherent in the wave function are realized, albeit in different universes. Consciousness and the quantum, a cosmic connection. The enigmatic nature of quantum mechanics has led some to speculate about a possible connection between consciousness and the quantum world. Could our minds, through some unknown mechanism, influence the outcome of quantum events? While this remains a fringe idea, it highlights the profound questions that quantum mechanics raises about the nature of reality and our place within it. Some physicists have proposed that consciousness itself might be a quantum phenomenon. They argue that the brain, with its billions of interconnected neurons, could be capable of harnessing quantum effects to achieve its remarkable computational power. While this remains speculative, the possibility of a deep connection between consciousness and the quantum realm is a tantalizing one. It suggests that our minds might be more intertwined with the fabric of reality than we ever imagined. The quantum theater, a grand illusion of reality. As we delve deeper into the quantum realm, we begin to see the universe not as a collection of solid objects, but as a vast and interconnected web of possibilities. The classical world of our everyday experience emerges from this quantum soup, a grand illusion woven from the fabric of probability and uncertainty. It is as if we are watching a cosmic play where the actors are subatomic particles and the stage is set with the laws of quantum mechanics. The act of observation, our conscious interaction with this quantum drama, collapses the wave function and forces the actors to choose their roles. But even as we marvel at the unfolding spectacle, we must remember that we are not merely passive observers. We are participants in this grand cosmic dance, our actions and choices influencing the very fabric of reality. The quantum world, with its baffling paradoxes and mind-bending possibilities, invites us to reconsider our place in the universe. It whispers of a reality far stranger and more wondrous than we ever imagined.